Hi there and welcome back to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes you, Algebra 1. And in this video what we're going to be looking at is exponential growth and decay. And it says up top in lesson 4 you learned about exponential functions in the form y equals a times b to the x. In lesson 5 you worked with percents. Today you will combine both of those methods of thinking to conquer exponential growth and decay functions. So it says here the exponential growth and decay formula is represented by y is equal to 1 plus or minus, y is equal to a times 1 plus or minus r to the t power. In this formula, a represents the y-intercept, r represents the percent rate as a decimal, and t represents the amount of time that has passed. So y equals a times 1 plus r to the t is used for exponential growth because, again, remember from lesson 5, when we add to something, it makes it larger. And we added to a couple of instances in lesson 5 where we got a larger number than we started with. And that's going to be why it's growth. While 1 minus r is going to be used for decay because we're subtracting from our original 100%. And that's why our exponential growth and decay formula is denoted with this plus or minus symbol. So can you see the general form of an exponential function within this formula? And when it says general form, remember we're referring to y is equal to a times b to the x. So again, if we're looking at this piece by piece, we have a and a. We have it times something. Here we have it times something to a power exponent. And we have all the same stuff here, but instead of the b, the growth or decay factor, we have 1 plus or minus r, which is going to be our growth or decay rate. So there's going to be two important terms that we're going to focus on, where b is going to represent our growth or decay factor, and r is going to be our growth or decay rate. They sound the same, but they are very different from each other. So in exercise number 1, it says create an exponential function that has a y-intercept of 200 and growing at a rate of 3%. So we're just going to fill in the information that we do know. And we do know the y-intercept, so that's going to be our a value, is 200, and a rate of 3% growing, so our r value is going to be 0.03. And if it's growing, we're going to be using the one where we add r to it. So we're just going to fill in this formula now. Y equals a, but we know a is 200, times 1. We're going to be using plus because it's growing at a rate of 0.03. And then we don't know how long we want it, so we're going to keep that t as the exponent. So again, this is the formula that we could use if we know the y-intercept is 200 and it's growing at a rate of 3%. Now let's take a look at part B, where it says we have a y-intercept of 1600 and it's decaying. Okay, so we know we're going to be using this formula over here, decaying, subtraction, at a rate of 12%. So we're going to have y is equal to, well, let's see, we know our a value, our y-intercept is going to be 1,600. We know we're decaying, and we know the rate is 12%, and 12% as a decimal is 0.12. So let's just fill in this information in our formula, and we have 1,600 times 1 minus, because it says to use 1 minus, the rate, 0.12 to the power t. And there we have our exponential growth formula and decay formula given a little bit of information. And I hope this video was helpful as an introduction to the exponential growth and decay formula. Please let me know that by giving it a thumbs up below. And you're now ready for exercise number 2. Thank you for watching.